Well, hello, students and seekers of general truths. Let us continue our discussion of parabola quadratic equations between standard and vertex form. And if you look at this previous problem, we were able to start out with something in standard form and convert it to vertex form. But rather than dealing with the tediousness or the tedium of this problem multiple times, let's just do it once. What's like the general or the most straightforward way to deal with this problem? And so we have here the vertex form, and then we have this here, which is the standard form. And we have kind of two choices. These two are equivalent of each other. They graph the same thing. If you plug in certain numbers, you'll get the exact same graphs. But we want to be able to figure out how does M and A and H and B and K and C, how are all of those related? And so we have two options. We could either complete the square with the standard form, or we can distribute the vertex form. I prefer to distribute the vertex form. Okay? So when we distribute the vertex form, we get that f of x is equal to m, is some number. X minus h quantity squared will give us x squared minus 2hx plus h squared plus k. Then we can multiply out the m. So we get mx squared minus 2mhx plus mh squared plus k. All right, so this is we take the distributive, the vertex form here, and we just distribute or multiply everything out. And then now we're going to compare what we have here to the standard form. So I'm just going to write this all together here. Mx squared minus 2mhx plus mh squared plus k. And then my standard form here, I'm going to write on the other side, is equal to ax squared plus bx plus c. Okay. Now let's compare variables. Let's go one at a time. So the variable in front of x squared is m for the vertex form version, and it's a for the standard form version. So that tells us that a must be equal to m. Okay. The second scenario here, we have, let me use a different color. Let's use purple. The variable in front of x in the standard form is b. Now, excuse me, not the variable, the constant, the number in front of x is b. And the number or the constant in front of x in the vertex form version is negative mh. So that tells us then that b is equal to negative 2mh. And we already know that m is equal to a, so we can just say that b is equal to negative 2ah. All right? So this is one good conversion factor, and I'll just box this one right here. This is another good way to do conversion. And then finally, this next part is quite messy and kind of gross, so we won't dwell on it too much, but c is the constant that's left over, and then mh squared plus k is what's left over is in the vertex form. So that tells us that we have c is equal to mh squared plus k. All right. Now what I want to do here is revisit the previous example, just to show you how this process here it can be helpful to us when we apply it back to this problem. So Here I have standard form. This is A, right? 6 is B, and negative 5 is C. Okay. Well, in vertex form, I know that my equation is going to look like this. It's going to be mx minus some number squared plus k. All right. Well, we know that m and k are the same, so it's going to be a negative 3 here. And then we can actually use this equation here. I think this one here is the most useful one. Okay, this equation here tells us that h is equal to b over negative 2a. So using this particular problem here, we know that h is going to be equal to 6, that's b. So I want to make sure that I know that this is a b here. 6 over negative 2 times a, which was negative 3, which turns out to be 1. Okay, so here, that's going to give us a 1, right? And then k, well, k, you could do all kinds of messiness here, but I think another way to find k is going to be f of h. Because remember that if we have if the vertex is located at hk, then if we plug in this value of 1 here, then that'll help us figure out k. So we know that h is 1 for this problem, so f of 1 is equal to negative 3 times 1 squared plus 6 times 1 minus 5. Okay, so let's evaluate all that. Negative 3 plus 6 is positive 3, minus 5 is negative 2. So we get our final answer. Okay? So I hope this procedure here helps you to kind of clarify how do we convert back and forth between standard form and vertex form. To go from vertex form or standard form, it's easy, just multiply everything out. To go from standard form to vertex form, you have to do a little bit more work, and this is the really key pieces of information here that I'll box this all in red. A and m are the exact same thing. It's not going to make a bit of difference. Okay, b is equal to negative 2ah, or h will be equal to b over negative 2a. Okay, and then finally, to find k, you're going to plug in, you're going to take h and plug it into f in order to get the value for k. Right, so there was a lot of letters being thrown around there. Ask for help, ask for clarification if you're having a hard time with it. As always, thank you for watching, keep working hard, and have a wonderful day.